Okay, so if you didn't see in my comments, I asked you all to get on HMH because we're starting our new story today. Dun, da, da, da. But it should be underneath assignments. It should say prepare to read my book, or it should say my book, prepare to read Quaking Earth and Racing Waves. If yours isn't loading, just keep trying. It's okay. Sorry, I had a dog hair in my mouth. Just keep trying to load. I was not planning on sharing my screen because I wanted to be able to see more of you today because I have so many questions to ask. But it's okay. You can listen. If your screen's not, if your HMH isn't loading, just keep trying. I'll show my dogs at the end, Evan. Right now, we're going to focus, okay? So, yesterday was vocabulary day, of course. So, we're just going to review our vocabulary words really quick. I'm going to say the vocabulary word. If you want to answer, raise your hand in the raise your hand thing. Don't actually physically raise your hand. Raise the hand button. I'll call on you, unmute yourself, tell me what it is. We're going to keep today moving, okay? Once again, I'm sorry if you hear a dog bark. Hopefully, they're good. So, our first vocabulary word that I'm going to ask today is parallel. Raise your hand if you want to tell me what parallel is. Presley, your hand was first. What is parallel?
Parallel means two different things that go in a straight line and will never intersect.
Yes, they'll never intersect. And remember, that is what is someone else. You don't have to answer this part, Presley. What is special about the word parallel? I said it like 14 times yesterday. It is what? If you remember, raise your hand. Olivia? Do you remember? No one? Anyone remember? Okay, well, Presley's hand's still up. So, Presley, tell me, what is important about that parallel that we talked about yesterday?
It's a math area content word.
Yeah, it's a content area word specific to math. So, like train tracks, parallel, they're never going to intersect. They're not just, a train can't randomly go like that. Okay, good job, Presley. All right, our next one was lateral. If something moves laterally, how does that move? Dylan Kelly? Dylan Kelly?
I didn't know my hand was raised. I raised it for the last question.
That's fine. If something moves laterally, how does it move, Olivia? Yes,
It moves from side to side.
Side to side. All right. The next one is destruction. Every single one of us should be able to have our hand up for destruction. We know what destruction is. Destruction is like the act of destroying things, right? Yeah, that one's pretty much self-explanatory. All right, the next one is triggered. Remember, if I push the first domino, that triggers the rest of the domino. So if you trigger something, you start an effect or you start an event or something like that. What does thrust mean? Raise your hand if you want to answer what thrust means. Jacqueline. Jacqueline?
It's like you're pushing something like really hard.
Basketball. It's going to be hard. It's going to be tough. It's not going to be no wimpy throw. Okay? Not going to be wimpy. And what is radiate? If something's radiating, what does that mean? Let's look whose hands are up. Mia, what does radiate mean?
Thing like goes off like a drop of water, then it spreads and keeps going.
Yeah, so radiate. To radiate is to spread out in waves or rays. So remember, if I throw a little pebble in a puddle, it's going to radiate little baby waves, right? Right. And then our final one is modified. Remember, Mrs. Kneifel is modifying right now because I'm in my home instead of at school. So I'm modifying what I'm doing today. Not really, but I'm not sharing my screen with you. That's one modification. So modifying is to change something or to make a better version of it, maybe to make it simpler. You can modify things to be harder, all those shenanigans. But those are our vocabulary words that we are going to hear within our story. So I need you on the prepared to read page, okay? So the genre this week is informational text. Informational. if this is informational text, can you tell me if this is fiction or nonfiction in the chat right now? This is informational text, tells about a topic, event, or place. Is this nonfiction or fiction? Write it in my chat. If we're reading informational text, is this fiction or nonfiction? All right, I'm seeing lots of right answers. It is nonfiction. These are the story we're about to be reading today is about a true event that happened in a true place. So we're going to read the bullet points underneath informational text. So, informational text may be organized informational text may organize ideas under subheadings. They contain main ideas and supporting details, including facts, examples, and sometimes quotations. Quotations are going to be a real something that someone really once said. So they'll be in quotations, and we will see some subheadings in here. And that's just how it's organized. Okay. So we'll talk more about those as we come along to them. Informational text may contain science or social studies words specific to the topic. Mrs. Kneifel, what does that mean? That's just a fancy sentence for content area words. We're going to see some words in here that are specific to content areas, such as math, social studies, or science. Okay, so we're going to come across those content area words. Sorry, I'm yawning. My goodness. And also, there's going to be visuals such as diagrams and maps, text features such as sidebars that tell more about the topic. There is going to be like a little sidebar in this story that tells us information, not directly to the topic. There's going to be visuals, there's going to be real pictures, but there's also going to be Hannah Druber. I'm not sure what you're doing with your camera right now, but it's really distracting. But there's going to be some diagrams and maps, and overall, it's a good, lovely learning thing. So, quaking earth, racing waves. Let me say that again. Quaking earth, racing waves. That is the title of our story. And it is an informational text. So when we hear quaking earth, what natural disaster do we think of? Put it in the chat. What natural disaster do we think of when we hear quaking earth? Because remember, we're still on module 3, all about natural disasters. So we're hearing quaking earth, so we can assume that it's about earthquakes. Yes, all you guys are typing in the correct answer. We're hearing quaking earth, so we can assume there's probably going to be something about earthquakes in here. Then there's something that says racing waves. What natural disaster might that be talking about? The quaking earth is earthquakes, but racing waves, what natural disaster might that be about? All right, you guys are spelling it crazy, but that is okay. Some of you are spelling it right, but I'm going to agree with you guys. Tsunamis. Yes, we're going to assume just by the title that this is going to be about earthquakes and tsunamis, okay? Because remember, sometimes that cause and effect, an earthquake happening can cause a tsunami. Or maybe it is about hurricanes. I'm not sure. There's definitely waves during a hurricane. So Rainier had a little bit of different thought. Maybe it's also about a hurricane, but most of us said tsunami. Obviously, we're going to find out. We have learned more about earthquakes in our past stories than we have tsunamis. But we are going to go ahead and get started. So please turn the page with me to page 1. Right off the back, we can see some stuffs in our book. We can see that it starts nice and bold in July 2004. So that's giving us an exact date of when something happened. And then right here, this would be one of our subheadings, rising coral. And then there's actually a real life photograph of coral in the bottom left hand. And then on the other page would be a diagram. So there's all this stuff just on these 2 pages. But I'm going to get started reading. So in July 2004, I don't even know, were you people even alive in 2004? No, you weren't. I was alive in 2004, but none of you guys were. That's a weird thought. Sorry, that was a total sidebar. So in July 2004, the village school on Telo Island, Indonesia, had visitors with a startling story to tell. Okay, so Indonesia. Where's Indonesia? Mrs. Kneifel is going to look up where Indonesia is real quick because I just don't know off the top of my head. Indonesia is officially the Republic of Indonesia, is a transcontinental country in Southeast Asia and Oceania between India and the Pacific Oceans. It consists of more than 17,000 islands, including Burano and New Guinea, etc., etc. From here, from where I am, from my cell phone, it would take 23 hours and 15 minutes to fly there, in case you're wondering how far away Indonesia is for us. So, yeah. But the Tello Island of Indonesia, all right, had a visitor with a startling story to tell. As the students in their red and white uniforms sat quietly listening to geologist Carrie Shy explain that under the ocean, 60 miles from their island, was a ticking time bomb. What? What does that mean? Obviously, there's not a real bomb underneath the island. So, this would be a figure of speech that this geologist is talking about. First off, geologists. Oh, what was that noise? Bryden, do you have a question, sir? Or something to say?
No, it's
Bryden?
not. It just raised the hand on its own.
Okay. I was just making sure that I wasn't skipping you. So, remember, a geologist is someone that studies like rocks, solid, people that would study things like earthquakes happening. Remember they study earth, exactly. So, because remember, geo means earth, ologist means study of earth. So there's this lovely geologist that's there explaining to these children at school, saying, hey, you guys got a ticking time bomb 60 miles away from you. Like, what the heck? What do you mean a ticking time bomb? What? And under the ocean. Why would there be a bomb underneath the ocean? Like, what is she talking about? Well, she studies Earth, so it's going to have something to do with Earth, most likely. For hundreds of years, the Sunda megahertz fault has been storing energy that would be released in massive undersea earthquakes. The powerful quakes would likely cause tsunamis, fast-moving waves that could wipe out the entire seaside village. So, the ticking time bomb is really what? Raise your hand if we now know what the ticking time bomb is. Like, raise your hand in the raise your hand thing. Don't physically raise it. Landon Rebus, what is the ticking time bomb Carrie Shy is talking about?
Like an earthquake.
Okay, a earthquake happening, but because of what? The ticking time bomb itself has a name. Do you know, Landon, or do you want me to call on someone else?
Call on someone else.
Okay, Abigail, what is this ticking time bomb?
A tsunami.
Okay,
She
Abigail,
was
I couldn't
really
hear you.
quiet, but she said tsunami.
All right, that is not the ticking time bomb. The ticking time bomb could cause a tsunami. What is the actual ticking time bomb, Bryden Weaver?
The ticking time bomb is energy stored up that could create an earthquake under the sea and then cause a tsunami.
Yeah, and it's specifically called the Sunda megahertz fault. That is the ticking time bomb, because that fault is where all the energy is being stored. And that is what she's saying is the ticking time bomb, because for hundreds of years, this fault, which is, fault is where, plates meet and all that crazy shenanigans stuff. All this energy is there. And eventually, one of them is going to move, just like in our media story from last week. We heard it instead of read it. Eventually, one of them's going to go underneath, and then boom, earthquake. But these are under the sea earthquakes. So the earthquake itself isn't going to be what's harming people. It'll be the tsunamis that the earthquake caused. And tsunamis, powerful waves, could knock out the entire seaside village. So in those two paragraphs, we already heard this little village, or this Tello Island, is probably in big trouble for when or if this earthquake ever happens. The students and their teacher were surprised by C's, I'm going to call her, what do I want to call her? Saya's, let's call her Saya's warnings. They'd never felt giant earthquakes or seen tsunami waves. How did he know the earth was going to shake? So the teachers and the students are like, how do we know we can believe this geologist? Well, because remember, geologists, that's what they do for a living. They study it. But they're kind of a little bit skeptical. Shai explained that for more than a decade, scientists from the California Institute of Technology had been studying sections of the fault just to the south. They figured out that major earthquakes shook the region about every 200 years. The last big quake was in the early 1800s, which meant another could come at any time. Though Sai couldn't say exactly when it would happen, he was almost certain there would be at least one major earthquake in the students' lifetimes. Can someone tell me right now why he can't say exactly when this earthquake's going to happen? Why can't he say on Tuesday, 2006, there's going to be an earthquake? Why can't he say that? Gage?
Because earthquakes are unpredictable.
Right. They are natural disasters. They happen naturally. Just like this, the geologist is explaining, they can try to predict it. They can let you know one's going to happen soon, one might happen, but there's no way to say the exact day, the exact time, the exact month. We can't predict that because they're natural disasters. They're things that occur naturally. So he's like, yeah, I don't know. What page are we on? We're on page 206. It's just the first page, Olivia. So, all he can say is in your lifetime, students, so students like you guys, your lifetime, so let's assume another 70, 80 years, hopefully we all live nice and long. Hey, guess what? There's going to be an earthquake in your lifetime. But no one could have known the next big quake would hit just a few months later. Snap. So the story started in July 2004, so a few months later, what year did this giant earthquake happen in? We should all be able to answer this. Jacqueline? I don't want a month. I want a year. What year did it happen in, Jacqueline?
2004 or 2005.
All right. So we definitely know it said a few months, and July is the 7th month. So we're going to assume it happened towards the end of 2004. Okay. So now we have a subtitle called Rising Coral. Coral, if you don't know, is like living plants underneath. They're in the ocean, but they are alive, but they look like rocks. Coral looks like rocks, but technically it's alive. Mrs. Knifel's not really into underwater stuff. I think it looks crazy gross, but that's totally besides the point. But we are on paragraph 6, Rising Corals. Scientists know a lot about earthquakes after they happen, but they can't predict what hour, day, year, or even decade an earthquake will hit. So how did Carrie How did Carrie Sai know to warn the Tella Islanders that an earthquake might happen soon? He could read coral. What the heck? Read coral? It's not like coral has words printed on it. That makes no sense. So we're about to find out how he could read the coral. In the Indian Ocean, big corals called porites grow from the sea floor to the water's surface, then outward. The ocean floor sinks slowly between earthquakes, dragging the coral down, then rises quickly during a quake, rising the coral up again. Over hundreds of years, all this up and down causes the coral to grow outward in donut-shaped rings. Sai discovered that by looking at the growth patterns in the porites coral heads near the fault, he could pinpoint the dates of past earthquakes and maybe find a pattern that would help predict future quakes. So this coral gets really, really big. The picture in the bottom right hand is an actual photograph of it, like a real life photograph, not a drawing. So this coral gets really big. So it starts on the surface, it grows to the top, and then once it hits the top, it grows out. Okay, then it grows out. But when earthquakes happen, the bottom of the floor rises and falls, which just causes this lovely coral to grow in crazy ways. Okay. So the scientists or the geologists have found out how the coral grows, and they're able to study it and tell, so they can look and be like, oh yeah, this happened so long ago. So that's how they know when the past earthquakes happen. Because obviously the geologists weren't alive in the 1800s when the last big earthquake happened. So just by studying the coral is how they figured out when the last one happened. which is how they can know another one might be happening somewhat soon. Using underwater chainsaws, Sai and other scientists slice off slabs of coral heads that were hundreds of years old. Sure enough, they found that on a section of the fault just to the north of the Mentawai Islands and just to the south of Tello, earthquakes occurred in pairs about every 200 years. One pair of earthquakes hit in the 1300s, another in the 1500s, and a third in 1797 and 1833, almost 200 years ago, according to the coral. It was time for another big quake. So, how did they study the coral? Did they just hang out underneath water forever? No, that would be crazy. So they took underwater chainsaws, who knew there were those, and cut the coral so they were able to bring the coral out of the water and really study it. So they're saying every 200 years, according to the coral, there's a pair of earthquakes. Pair means two, like a couple, pair, two. So there was a pair in the 1300s, a pair in the 1500s, and then the third pair was in 1797 and 1833. So that's where a pair of earthquakes, even though they were over 30 years apart. So like the people that were alive in 1797, like 30 years later was the second one. Those are a big gap between those pair of earthquakes. But regardless, these geologists, these scientists really think, hey, another one is going to happen soon. So now I want everyone to look at this diagram of the coral, and we're going to just read more about this lovely coral, okay? This is a diagram. This is hand-drawn. This is not an actual photograph, okay? So, this coral, when it reaches the ocean surface, coral's heads stop growing upward. Only the sides, which are still underwater, continue to grow outward in rings, like the growth rings of a tree. You can tell how old coral is by counting the rings. Just like if you were to cut open a tree, you guys have probably heard you can count the rings and see how old the tree is. So it's kind of like the same thing as coral. But once coral hits the surface of the water high, it can't continue to grow because it can't grow out of the water, which is why then it grows wide, okay? So instead of growing tall, it grows out wide. Between earthquakes, the ocean floor is slowly sinking, and the coral, which is attracted to the ocean floor, attached to the ocean floor is sinking too. The coral head drops below the water line, and then the sides grow up to the water surface. So now, can we all see how there's the original ring, but now the sides are going to grow up to the ocean surface again, okay? It's just crazy how it's growing. I know it's kind of hard to understand, but this is just how it grows. And we know this based on all this crazy research. During an earthquake, part of the ocean floor springs up and some of the coral heads are lifted half out of the water. The section of coral above the sea dies, while the part still under the sea keeps growing. From above, the coral looks like little donuts inside a series of bigger ones. So just how it grows, we all know what a donut looks like. It's a circle, and then it looks like there's a little circle donut, and then with a donut around it, and then with a donut around it, and then with a donut around it. Kind of silly. But that's kind of how this specific coral grows. Not all coral is going to grow like this. Not all coral you're going to be able to predict an earthquake with, but this specific coral can help the geologists and scientists predict earthquakes. So, let's do a little refresh. Why did Sai study the growth patterns of the coral near the Sundown Megaherst Fault? What was the point or the goal of studying this coral? Someone remind me. Raise your hand in the actual raise your hand feature, and I might call on you. What was the point of studying this coral near this Sundown Megaherst Fault? What was the goal of it? What was the point of it? Dylan?
The point of it was to see if they can
find patterns from past earthquakes to see if they could predict future earthquakes. So they were studying this coral specifically close to this fault line. Because if I studied coral that was 2,000 miles away from the fault line, okay, well, that's not going to be affected by an earthquake, so that wouldn't help us studying that coral. They studied the coral specifically to close to this fault line to see if they could find a pattern, to see when things happened in the past, to see if they could predict the future. And obviously, Cy, this lovely geologist, has predicted that they happen every 200 years. So he's telling the teacher and the students of this island school that, hey, one's going to happen soon. All right? You may turn the page. A lot of pages. We're probably not going to finish it today, Mia. Okay? So, sinking islands. This is another lovely, not sidebar. That's not what I'm looking for. Subheading. Not sidebar. Subheading. Sorry. All right. So, paragraph 9. The corals weren't the only evidence of underground rumblings in Indonesia. The Sundan Megahertz Fault at the bottom of the Indian Ocean marks the collision between the two plates that make up the Earth's surface, one oceanic and the other continental. So it's kind of like what we talked about in the past. Remember, two plates meeting? Those are where fault lines are going to be, and those are where earthquakes are going to happen. Between earthquakes, the plates are stuck together as the oceanic plate slips slowly downward. It squeezes the continental plate sideways about half an inch a year and drags it down a few inches a year as well. The island on top of the continental plates are dragged down too, as much as half an inch a year. The more years between earthquakes, the more the islands sink and the more stress builds up at the fault. Of course, here we are at the fault line. Every year we don't have an earthquake, the pressure just builds and builds and builds. So it's been 200 years since the last earthquake. Well, about 200 years since the last earthquake. So obviously, could you imagine the pressure that's built up in 200 years? It's probably absolutely crazy. So there's going to be all this pressure, and that's what the geologist was studying, knowing there was going to be a huge earthquake soon. Islanders could tell that the water line was shifting. They can see their boardwalks and harbors sinking, Cy said. Trees that once grew tall on shore are now underwater, and wells that once gave fresh water were full of salty seawater instead. But no one thought that this had anything to do with earthquakes or tsunamis. So the people that live on the island can tell that over time, a half inch a year is not very much, okay? A half inch is like your knuckle here is an inch long. So half of that knuckle is how much the island is sinking every year. That would be really, really hard to tell over time. But, 10 years pass and that's 5 whole inches. So you'd be able to tell if something's 5 whole inches. But the sinking of the island and the piers and the trees and stuff are happening really slowly. So you don't see them like on a day-to-day thing. And people that live on the island were just thinking, oh, yeah, it happens. It's just sinking a little bit over time. They weren't realizing it was because that the oceanic plates and the continental plates were dragging the island down, okay? So they had no idea it was going to be, have something to do with earthquakes and tsunamis. They just, think they're whatever. It's just, it's fallen a little bit. No big deal. Evidence from global positioning systems or GPS stations they'd set up to measure island sinking also have convinced the scientists that a big quake could rock the area at any time. As we came to realize what we were learning and how much at risk people were, said Cy, we couldn't keep quiet. So, you can see in that little picture in the bottom right hand, I'm going to read the caption. Remember, all the time there's normally captions with pictures, with photographs. The geographer prepares a GPS station in Indonesia to collect data. So this would just be one of the little stations that collect data. And basically every single day it measures the height of the island and stuff. And over time, you could see it going down. So they're saying these scientists that are studying it, they think that it's so possible to happen soon that they need to let people know. In July 2004, Cy visited 5 islands and gave presentations at schools, churches, mosques, and village squares. Cy and his colleagues plan to return the following year to visit more islands and teach more people about their research. Then, 6 months later, a quake struck. Snap. So, Mr. Tsai in 2004 was doing all he could to warn people about the earthquake's potential of coming. He went to schools, he went to churches, mosques, which are another type of like religious building. He went to village squares, which would just be like a big area where people gathered. So, him and his colleagues, which would be who he works with, are trying to tell people as much as possible that bad things could happen. And guess what? 6 months later, a quake struck. Snap. 6 months? That's not very much time. So they obviously didn't think one was going to happen that fast. So they didn't get to tell as many people as what they had wanted to. So now on the following page, it says, what makes the earth quake? This is a full sidebar. Can someone tell me what a sidebar is for? What is the purpose of a sidebar? Mia, can you tell me what the purpose of a sidebar is?
So a sidebar gives you some side information about something that has to do with the story, but it's not necessarily fully about the story, but it's something that has a little bit to do with it, and it tells you more information and facts.
So a sidebar gives us information and facts about either a topic in a story or, an event in the story or something like that, but it does not necessarily follow along with the story. That's why it's off to the side. It's also a different color. In this one, it's dark brown on the back. So this is extra information about, obviously, earthquakes. The title is What Makes the Earthquake. So this author is choosing to give us more information about earthquakes in the middle of our story about earthquakes. So, what makes the earthquake? Next time you're outside, jump up and down, stomp your feet a few times. The ground seems solid, right? Well, not entirely. The part of the earth you're standing on, called the litmosphere, is rock solid, but the litmosphere is very thin. If the earth were the size of an apple, the litmosphere would be about as thick as apple skin. If you dug a hole through the earth, you'd find that as you went deeper, that insides becomes hotter and more gooey. The solid litmosphere is broken up into close-fitting plates that drift on top of molten rock underneath. We don't feel the plates moving because they're usually drifting only a few centimeters a year, about as fast or slow as your fingernails grow. So all this is happening underneath us right now as we are speaking, but we can't tell because it only moves, a few centimeters, like less than an inch a year. So we would never be able to feel that in real time. Earth's plates don't all move parallel to each other and in the same direction. At the boundary where two plates meet, called a fault, they bump and push into each other. So they're saying Earth's plates aren't all just moving the same direction all the time right next to each other. Instead, just like we've learned in the past, they kind of go like this. And one might accidentally go on top of each other. And that is where all that pressure builds. So they don't move along side by side perfect. They hit, they bump, and that's where those fault lines create. And that's where the pressure comes. And that's how we get our earthquakes. They wedge together most of the time. But stress builds up as plates bump and grind each other. Finally, the plates break free along the section of a fault, releasing pent-up energy in an earthquake. The force makes objects move up and down and in a lateral motion and causes great destruction. We already know that earthquakes can cause a huge amount of damage. There are several different types of fault. The Sundance Fault offshore from the Batu and Metawati Island is called a megahertz, where the underwater oceanic plate dives under the continental plate. Okay, so there's different types of faults, but this one is specifically called the Sundance Fault, and it is a megahertz, and it's called the megahertz because how the plates are on top of each other. Does Mrs. Kneifel know what the other types of faults in her fault lines are called? No, I don't, but this one's called the megahertz because how the plates are on top of each other. So we use parallel, which remember run side by side, never intersect, which are our plates in our lovely earth do not do that. They do the exact opposite. They bump into each other all the time. Lateral means side to side, and we all know what destruction means. Okay, so what comparison does the author use to help us understand the litmosphere and how it's really thin? The author compared our Earth to something. What was the object our author used to compare our Earth to? Elijah, do you know?
Or
I told him, I said,
parallel?
it's your daddy.
They are parallel. Earth can be, but he was talking about the plates. We're talking about the litmus sphere. It's a little higher up in the paragraphs. The litmus sphere, remember, is the first like edge of our lovely Earth. What sorry. Someone actually put it in the chat. It is the apple. Remember, the author said the litmus sphere, which is the outside top of our ground, is like very thin, just like if the Earth was the size of an apple, the litmus sphere would be the apple skin. So the author compared the Earth to apple skin. Okay. How does the author explain how slowly the plates move each year? This was another like metaphor. He said they move only a few centimeters a year, which is about as fast as what? What did the author say? About as fast as. It was a simile used. Jessica?
They compared it to how much your fingernails grow.
Yeah, just like you couldn't look at your fingernail for however many days and weeks and see that grow. You would never be able to actually see it in real time. Just like in real time, we can't see the Earth's plates moving or anything like that. So the author explained that plates move only a few centimeters a year or about as fast as a person's fingernails grow. And then I also think that the author used some good adjectives to describe I lied. They're not adjectives. They're verbs because it's something that you do. The author used some vivid verbs to help us visualize what happens when the Earth's plates move. Can anyone find any of those verbs? It's in like the bottom of the first paragraph and the top over here. Can anyone, do you know what verbs I'm talking about? The Earth does what? Dylan?
It bumps and grinds
Right.
together.
And then it also breaks free. All of those, like the author could have been like, yeah, the plates move. No, he's like, they bump together, they grind, they push against each other and they break free. So I thought the author added those good verbs there. I enjoyed those verbs. All right, I want you guys to turn the page. And now we are back to our regular story. So our sidebar is over. Our first sidebar is over, and we are back to the actual story. Our story started in July, and now we are on December 26, 2004. So it's still 2004, but we're in December 26th now.
Mrs. Kneifel,
Yes,
Mia's saying, wait a second.
but I can't wait. I gotta go. Just if your book's not there, just listen, okay? So the ground shook so violently that people were knocked off their feet. Dishes fell from shelves, roofs collapsed, trees toppled. 2 minutes after it began, the shaking stopped. It had been the biggest earthquake on the planet. No, it had been the biggest earthquake anywhere on the planet in 40 years. Oh my gosh, snap. The biggest earthquake on the planet in 40 years, but it was only 2 minutes long. But even though it was only 2 minutes, I bet those 2 minutes felt like a lifetime for people. Like a twig, you bend and bend until it breaks. Pressure that had been building along the Sundance Megahertz fault for hundreds of years had finally given way, along a section of the fault line longer than the state of California. The oceanic and continental plates suddenly, violently separated, which triggered earth-shaking waves. But the worst was still to come. Okay, so the spot on the fault line, it was as long as the state of California. Okay, that is crazy. That's really long. This California is like the biggest state in the United States. So absolutely huge. And remember, there can be cause and effect. So this earthquake triggered other things to come. And according to this last sentence, but the worst is yet to come. We can make a prediction right now. After this crazy long earthquake, or this crazy earthquake that was super big, it's going to trigger what? Put it in my chat. What is it going to trigger? Yeah, absolutely. You guys are right. It's going to trigger a tsunami. We know that based on what we've already learned about tsunamis and earthquakes and stuff like that. we are going to read the little sidebar that is brown again. So remember, this is extra information that goes along with our story but isn't necessarily part of our story. No ordinary waves. Most waves are formed by wind that blows across the ocean surface, pulling water with it. But a tsunami is started by a disturbance, such as undersea earthquake, that shifts water on the ocean floor. Water is thrust up from the bottom of the sea all the way to the ocean surface, and waves begin to radiate out in all directions. As a tsunami wave hits the shallow water near land, it slows down but grows taller. Water at the shore is sucked into the giant wave, exposing fish, shells, and coral that were underwater moments ago. Then suddenly, a towering wall of water crashes onto a beach. So that's just giving us a little bit of information about waves. So normally waves are just caused by wind. You know, winds going across water, some water is drugged by the wind. But instead, tsunamis happen because something happened underneath the water and just causes these giant waves. Obviously, tsunamis, we know, can cause big destructions. So I need someone to explain to me what happened on December 26, 2004. In your own words, explain to me what happened in paragraph 13 and 14. Raise your hand if you want to explain in your own words what happened in paragraph 13 and 14. I want more volunteers. Someone I haven't talked to. There's so many of you on here. What happened on the 26th of December? Presley, tell me what happened on the 26th of December, ma'am.
The earthquake hit and it caused a lot of destruction.
Right. And how long was the earthquake? Everyone, say it to yourself. 2 minutes. And it said people literally were knocked off their feet, but the worst is yet to come. So we are going to read all about the worst is yet to come tomorrow. So we are going to stop here for today. Do not get off yet. I repeat, do not get off yet. We still have 3 minutes left in reading class. So today we read 2 sidebars and we read the first few pages of our story. So tomorrow we're going to finish reading our story and we're going to read about what is the worst to come. We don't know what the worst to come is yet, and we don't really know how much destruction it has caused for these islands. We just know it was the worst in 40 years. So today you do not have any reading homework besides you need to read for AR, okay? I was looking at AR points and I'm really worried about some of you guys. Some of you guys still have 0 points. That's not okay. So tomorrow we will pick up with this story, but today you need to find time today to read for AR for at least 20 minutes, but that is your only reading homework. Also, since I am at home, my Wi-Fi probably moves a little bit more slower. So the upload of this recording probably will take a little bit longer to get online. Just letting you know, if you want to come back and watch this again, it might take a little bit longer to get up. So here's Mr. Benji. Hopefully you saw him. He was sleeping because I needed him to be safe and sound and sleeping and not bothering mommy while I was doing this. So thank you all for joining today. I don't know where Bristol is. She's hiding somewhere. But no reading homework today besides reading for AR, okay? And I'm not giving you homework because I want you to read for AR. I'm going to let him out now that I'm done teaching, Evan. So I will see you guys tomorrow in reading class, my class, homeroom. I'll see you guys at 1 o'clock for grammar, okay? I'll see you guys at 1 o'clock for grammar. Mia, yes, you're totally right on what we've learned so far. Awesome.
Miss Knifel?
Yes.
My grandma's dog is named Bristol.
Oh, nice. Twins. Yeah, that's my one dog's name, and the other dog's name is Benji.
Bye.
All right, guys. Good luck on your math test. Do your personal best, okay? Do your personal best in math. I believe in you guys. Good job today. Thank you guys for paying attention, following along. Great job. Good luck in math. You guys are all free to leave.
Bye.
No homework, okay? Just read for AR.
Have a good day.
Bye.